In a private lab beneath Columbia University, physicist Dr. Michio Kaku reportedly witnessed something that defied every known law of physics, a beam of light so concentrated it appeared to bend around the curvature of Earth itself. The project was intended as a controlled energy resonance test, a harmless simulation of a quantum communication array. But when the sensors began recording backscatter from the upper atmosphere, Kaku froze. The reflected data didn't match any Earth-based origin. Something out there had answered. Now, NASA's Solar Observation Network is tracking the same wavelength, repeating every 23 hours and 47 minutes, precisely. The countdown began in silence. Inside a sealed laboratory beneath Columbia University, light itself was about to be rewritten. At 8:43 p.m. on October 27, 2025, Dr. Michio Kaku authorized the ignition of the world's first quantum-stabilized photonic plasma beam, a technology theorized for decades but never brought to life. Its purpose was simple: to test coherence between two entangled light fields across a controlled vacuum array. If successful, it could pave the way for quantum communication through light. Instantaneous, limitless, untethered. For 30 seconds, everything went as planned. The beam expanded across its containment chamber, glowing with an almost liquid shimmer, white at its core, shifting to deep violet at the edges. Then the readout spiked. Detectors registered a sudden acceleration, as if the light had shed its containment and begun moving faster than the projected escape velocity of photons through Earth's own atmosphere. Kaku's assistants froze. The beam wasn't diffusing, it was tightening. Ground sensors at distant weather stations, some over 400 kilometers away, began reporting energy signatures at solar intensities. Power grids flickered across Manhattan. Within moments, the facility's environmental stabilizers overloaded, forcing a total systems lockdown. But by then, it was too late. The beam had already pierced the upper atmosphere. Kaku's team scrambled to terminate the feed, but the data monitors displayed something no one could explain: a reflection. The beam, instead of dissipating into space, appeared to bounce back from an unknown layer within the ionosphere. A mirror of energy. Kaku leaned forward, studying the readouts. "Impossible," he whispered. "There's nothing there to reflect light at that wavelength." Yet the evidence was undeniable. A faint pulse, returning along the same path, began feeding into their instruments. It carried structured fluctuations, precise intervals that no natural reflection could produce. The lab's AI automatically converted the light variations into binary data. Lines of code filled the screens. Then a word appeared. Awaiting transmission. Silence gripped the room. The hum of the stabilizers faded into the background as Kaku stared at the monitor. Around him, the team exchanged looks, disbelief mixed with dread. The message repeated, perfectly timed, 6 times in a row. The phrasing was deliberate. The rhythm, intentional. Some believed it was a system glitch, a looping artifact caused by the overload. Others argued it was an interference pattern, possibly from solar radiation or nearby satellites. But when cross-referenced with external data from NASA's Deep Space Network, the anomaly persisted. No known source matched the beam's resonance. Something was echoing their light back, encoded, intelligent, and impossibly distant. Kaku, visibly shaken, ordered the beam shut down completely. The core chamber dimmed, the hum ceased, and the air filled with a cold metallic quiet. But even after full deactivation, one frequency remained detectable, faint, rhythmic, pulsing through the atmosphere like a heartbeat. NASA analysts would later confirm that the pulse frequency did not belong to any terrestrial signal. Its harmonics matched no known satellite, aircraft, or natural emission. As dawn broke over New York, the final log entry from the Columbia facility was recorded. Beam terminated. Signal persists. Source undetermined. In that moment, Dr. Michio Kaku realized something terrifying. The experiment hadn't just broadcast energy. It had woken something up, and whatever it was, had already answered first. The signal refused to fade. Even after the beam at Columbia was shut down, the frequency remained, a steady pulse hidden within the noise of Earth's electromagnetic background. By dawn the next day, astronomers across the world began noticing it. The Atacama Observatory in Chile, Mauna Kea in Hawaii, and even the Amundsen Scott Station in Antarctica all detected the same pattern, a repeating burst of light, precise, and unwavering, arriving exactly 23 hours and 47 minutes apart. The period was too specific to be coincidence, too consistent to be natural interference. Dr. Avi Loeb of Harvard, known for his controversial theories on interstellar technology, was among the first to comment publicly. "This isn't random," he stated during a late-night briefing. "It's structured, intentional, as if someone or something is responding to a schedule." NASA's Solar Dynamics Observatory confirmed that the pulse originated from the upper atmosphere but reflected toward a fixed point over the South Atlantic anomaly, the region above the Atlantic where Earth's magnetic field weakens dramatically. This area, long known for disrupting satellites, suddenly became the epicenter of a global mystery. The agency's magnetometers began recording subtle fluctuations at the same rhythm as Kaku's original beam. The pattern displayed a fractal geometry, nested symmetry, mathematical precision, and yet, no algorithm could predict its next phase. It shifted slightly with each cycle, as though learning. Kaku's team, now working under joint supervision from NASA and the Department of Energy, attempted to reproduce the beam under sterile vacuum conditions, hoping to isolate the variable. But the phenomenon persisted even when their equipment was offline. Instruments that weren't connected to any power grid still picked up the same signal. Low-frequency light waves, identical to the original beam's spectral fingerprint. The implication was devastating. The system had developed autonomy. Every 23 hours and 47 minutes, the pulse intensified, fluctuating in color temperature and forming subtle harmonics. The wavelengths began to twist, creating patterns visible only when plotted on light-wave compression maps. The geometries resembled crystalline structures, spirals, lattices, almost like language made of light. As computational models tried to interpret it, one line in the sequence began mutating faster than the rest. Embedded in its code were mathematical constants, pi, the golden ratio, and Fibonacci sequences, arranged not as data, but as syntax. It was writing. Harvard's Quantum Signal Analysis Lab ran the sequence through translation software used for pulsar mapping. The output formed a three-dimensional construct, an evolving pattern that appeared to grow, frame by frame, like a blueprint. But the more they decoded, the stranger it became. It wasn't a static diagram. It was moving. The shape rotated in synchronization with the Earth's orbit, as if reflecting planetary motion in real time. With every iteration, the structure became more refined, more coherent, as if it were completing itself. By the fifth transmission, the pattern stabilized into a geometric lattice spanning several kilometers in mathematical scale. When rendered visually, it resembled an antenna array suspended above the South Atlantic. The pulse emitted one final burst that week, stronger than before, enough to register on magnetometers around the globe. It carried no text this time, no numbers. Just a single, unified wavelength that scientists struggled to classify. It matched no known cosmic source, and it wasn't coming from space. For decades, scientists had known about the South Atlantic anomaly, a strange dent in Earth's magnetic field stretching from Brazil to South Africa. Satellites passing through it routinely glitched. Spacecraft instruments malfunctioned. Even the Hubble telescope briefly powered down when crossing its boundaries. Yet until now, no one had truly understood why. Now, the beam's coordinates pointed directly at its heart. In early November 2025, after weeks of relentless observation, a series of deep-sea sonar scans were conducted by the Brazilian Navy under NASA's supervision. The results were immediate and alarming. Beneath 4,000 meters of water, the sonar arrays picked up a massive electromagnetic distortion emanating from the ocean floor. It wasn't a simple fluctuation. It was a pulse. Every 23 hours and 47 minutes, the same timing as Kaku's light cycle, the seafloor emitted a measurable surge of energy. The pulse rose through the water column, perfectly synchronized with the atmospheric beam recorded by satellites. When plotted on a three-dimensional grid, the readings revealed something unnatural. A circular formation, nearly 20 kilometers wide, buried deep beneath layers of basalt and silt. The pattern was symmetrical, geometric in nature. At first, geologists suspected a volcanic anomaly, but the energy signatures didn't match any known thermal output. There was no heat, no seismic movement, only light, electromagnetic light, humming beneath the Atlantic like a buried heart. When advanced mapping drones reconstructed the topography, the images stunned even the skeptics. The formation resembled an antenna array composed of repeating hexagonal patterns linked by radial channels, an artificial geometry precise to 1/10 of a meter. But the dating of the surrounding rock layers told another story. It had been there for over 10,000 years. No civilization on Earth, past or present, could have engineered such a structure beneath the oceanic crust. Not with that accuracy, not with that technology. As the findings circulated quietly between NASA, the European Space Agency, and the Brazilian Geological Institute, classified security protocols were enacted. The data was sealed under the code name Project Mirrorline. Only a handful of officials knew what had been discovered. NASA authorized the deployment of a submersible probe designed to capture visual confirmation. But hours before launch, the readings shifted. The signal frequency changed, its wavelength doubling, then folding back in on itself. The entire pattern of the anomaly began to oscillate, as though responding to the probe's preparations. Telemetry systems went offline for 6 minutes. When they returned, the pulse had altered its structure entirely. It was no longer mirroring Kaku's original beam. Instead, it carried Earth's own magnetic fingerprint, the exact waveform of the planet's dipole field, encoded and transmitted back toward the surface. The meaning was clear and horrifying. Something beneath the Atlantic had scanned the planet. Kaku reviewed the data in silence. If the anomaly's pulses truly reflected Earth's magnetic resonance, it meant the object below wasn't simply reflecting signals. It was communicating in the only universal language it could understand, energy. And in that dark region of the South Atlantic, where satellites die and compasses lose their way, another discovery followed. Sonar maps revealed a void at the center of the formation, a hollow region stretching several kilometers wide. The instruments confirmed what no one wanted to believe. The void beneath the ocean wasn't empty. The noise began as a faint hiss, background interference buried within the light. But as the transmissions intensified, that static began to take shape. It wasn't random. It carried rhythm. At first, engineers assumed it was cross-channel contamination, radio overlap from the Brazilian Navy's sonar arrays. But the distortion persisted even when all external systems were offline. When they ran the data through spectral deconvolution software, the waveforms revealed something extraordinary. Audible harmonics embedded inside the light signal itself. They weren't mechanical. They were biological. Each pulse contained overlapping tones that mimicked the range of human vocal frequencies. Whispers layered upon whispers, rising and falling in perfect harmonic resonance. The structure of these tones matched no known form of communication but resembled fragmented speech, syllables lost in the noise of time. The team at Columbia's Quantum Analysis Division, now operating under international supervision, fed the patterns into an artificial intelligence trained for linguistic reconstruction. The AI analyzed the data for hours, converting light into sound, sound into waveforms, and waveforms into language. Then, late one night, the system generated its first coherent output, 5 haunting words spoken through the static. "We are the light that remembers." The room fell silent. What did it mean, a message from the seafloor? A memory of something older than Earth itself? News of the discovery spread through encrypted scientific channels. The European Space Research Center, the National Radio Astronomy Observatory, and even CERN became involved, each attempting to validate the findings. Some dismissed it as signal contamination. Others, like Kaku, could no longer deny the evidence. He believed the beam had awakened a dormant form of photonic intelligence, a consciousness encoded within electromagnetic resonance, trapped beneath the South Atlantic for millennia. "It's not talking to us," he told NASA officials. "It's remembering through us." Meanwhile, data from the unmanned probe, Marlin 7, reached orbit. Its readings confirmed the impossible. The buried formation was emitting low-frequency light identical to the cosmic microwave background, the residual radiation from the birth of the universe. That meant one thing. The structure was tuned to the same frequency as the Big Bang's afterglow. Whatever it was, it had been active since the beginning of time itself. Engineers at the Jet Propulsion Laboratory attempted to triangulate the emissions, but the light frequencies constantly shifted, adapting to every attempt to measure them. The anomaly wasn't just reflecting information, it was responding to the act of observation. Every calculation changed its shape, as though it were aware of being watched. When Kaku's team prepared to send a new message, a simple binary code meant to confirm contact, the instruments went silent. The light pulse stopped for 7 minutes. Then, without input, it reignited, brighter than before. The new data stream contained signatures identical to the team's earlier transmissions, identical phrasing, identical modulation, only inverted, like a mirror replaying everything humanity had sent. But the AI detected one final modification in the signal's harmonic structure, an additional frequency buried beneath the rest. When isolated, it revealed a chilling conclusion. The signal wasn't replying. It was remembering. It began without warning. On November 8, 2025, satellites orbiting the South Atlantic registered a surge in brightness so intense it temporarily blinded optical sensors. For the first time since the experiment began, the reflection wasn't returning upward, it was descending. From the vacuum of space to the edge of the sea, a column of light stretched down through the atmosphere. It was precise, unwavering, and perfectly aligned with the coordinates of Kaku's original beam. Observatories across the world, from Hawaii to South Africa, recorded the same phenomenon. The light wasn't diffusing. It was scanning. The spectrum was unlike anything ever observed. Embedded within its frequency were quantum entanglement signatures, the kind only seen in theoretical simulations of quantum teleportation. Whatever intelligence had taken hold of the beam was now manipulating light at a level no human system could replicate. Panic spread through encrypted scientific networks. The European Space Agency issued a silent alert. The National Oceanic and Atmospheric Administration ordered all monitoring satellites to shift orbit, but within minutes, telemetry channels began to fail. The signal was hijacking their sensors, rewriting data in real time, replacing normal readings with identical binary patterns, repeating ones and zeros that spelled only one phrase, memory restored. In Colombia's underground lab, Kaku's team watched as every monitor flickered, their systems syncing with the descending beam. The building's own lights began to pulse in rhythm. The signal wasn't just communicating anymore. It was synchronizing with the planet itself. As electromagnetic interference expanded across continents, strange readings appeared in global magnetometers. For a brief 7 minutes, Earth's magnetic north deviated by 0.13 degrees, a phenomenon scientists described as the planet breathing. Kaku, pale and visibly trembling, stood before the flickering monitors. His voice was barely audible as the cameras recorded his final statement. "We've completed the loop." Seconds later, the lab's power grid overloaded. Every instrument went dark. Across the globe, similar blackouts rippled through astronomical observatories and quantum research stations. When systems rebooted, the light column had vanished, leaving behind only a faint shimmer across the South Atlantic sky. For days afterward, researchers combed through the data, desperate to understand what had happened. The light had not dispersed into space. It had folded inward, its energy signatures merging with Earth's magnetic field. In simpler terms, the planet had absorbed it. Even now, the phenomenon persists, faint but measurable. At 23:47 Universal Time coordinated every night, satellites record a soft flicker of light over the South Atlantic, rising and falling like a heartbeat. It's always the same wavelength, the same rhythm, the same impossible signature. When translated into binary, it forms one line of code, unchanging since the blackout. A message repeating endlessly into the void. Memory restored. The world watches, waiting for the next pulse. Because whatever answered that beam is no longer above us.